Hello and welcome to Module 22, which is human population numbers. So if we look at human population numbers, humans have grown quite fast over the last few hundred years, few thousand years actually. But scientists, if we look at the carrying capacity of Earth, there's a little bit of disagreement. So some scientists feel that we've reached our carrying capacity now at a little over 7 billion. Some scientists think that our carrying capacity may be more like 10 billion. But it really comes down to how well at this point we use our resources. So if we are better adapted at growing things, maybe less wasteful, then our carrying capacity is much higher. If we continue to use things like we do today, and the developing countries use things more like we do, then our carrying capacity is probably less than it is now. So it just depends on our limiting factors and how we decide to use them, which is mainly food and water. All right, so if we look at this, this is the advent of agriculture, so right in here. And then notice how it's pretty steady incline of growth. So not very dramatic, pretty steady, but low. And then we get to here right after the Black Plague, the plague anyways. And then we get to about 1600. So it's kind of steadily increasing here, a little dip right there because of the plague. But then once we get to basically the Industrial Revolution, modern healthcare, or at least ways to better adapt healthcare, cleaner living conditions, for example, the population has just exponentially grown. So quite dramatically since the 1600s has it increased. So humans have grown dramatically fast in the last 400 years. All right, so the factors that drive human population growth would be these factors. So population size, birth and death rates, fertility, life expectancy, and migration. So those things, we'll talk a little bit about each of those things, but they're pretty self-explanatory. What are birth rates versus death rates? If we've got higher birth rates, then we're going to have an increase in population. How fertile is the population? So are they childbearing age? Are they older? Are they younger? What is the life expectancy? It's not all the same in all countries. And then migration, so moving in and out of an area. All right, so if we look at this, immigration, so there's two types of immigration and emigration. So immigration is coming in to the population, emigration is moving out. So people immigrate into the US, and then if you move out of the US, you're emigrating out of the US. And then we've got births versus deaths. So these are two factors that are going into the population size, and these two factors are going out. So they decrease the population. And so this is kind of interesting. I wanted to show you the population clock. So give me a moment to get there. So it's pretty interesting how, if we just watch this for a moment, but it's pretty interesting how watching the U.S. population growth versus the world, and this is current, so they just take the average for the entire year and then apply it. But it's pretty kind of eye-opening, I think. So one birth every 9 seconds, one death every 11 seconds. So our birth rate is a little bit lower than or a little bit faster than our death rate. So we're increasing in population. And then there's one international migrant every 46 seconds. And we gain, so if you factor in all of these things, we gain one person every 20 seconds in the US. And then the world population, so we can see the top 10 most populous countries. So China and India, by far, much greater population than the US, billion more or so. And then you've got other countries behind that. So pretty amazing how fast this clock is increasing, I think. All right, so, and then a world population video, I want to show you this as well.
An environment is a system of living things. The earth is our environment. The capacity of our environment to provide space, to produce food, and to supply energy are all limited. Humans thrive on less than 17% of the Earth's surface, and only about 4% will grow crops. We depend on these limited resources for our survival, yet we are increasing our population as if they were infinite. This fact is at the core of our environmental problems. On this map, we'll show population growth from the year 1 CE to the present, and project our growth into the year 2050. Population concentrations will be indicated by dots, each of which will represent 1 million people. In areas where people are spread out and don't live in concentrations of 1 million, dots are placed in the middle of their approximate range. Historical references will be provided by images and text at the bottom of the screen.
So it's pretty amazing here in a moment. So pretty steady, kind of like we saw on the graph that I showed you a couple slides ago. And then we're getting closer and closer to that 1600 time frame when the population just really explodes. So it's kind of amazing to see those dots disappear during the Black Plague. That was pretty significant. And now we're getting closer to that 1600 time.
Our population is expected to grow to 10 billion by the end of this century. Yet the Earth's size remains the same. Slowing human population growth and lowering our use of natural resources are key to reducing the impact we have on the planet. Through the decisions we make about our lifestyles, our numbers, and our consumption, we can all help preserve the health and beauty of our home.
All right, so kind of interesting there. All right, so if we look at population, there's a lot of different, there's a lot of math for this one. But we're calculating the population growth, exponential growth, doubling time, which is all very important in understanding our capacity and our growth and population on the Earth. So a couple different equations here. Global population growth rate. So this is birth rate minus death rate. So this would be divided by 10 in order to get your population growth rate for the globe. And then for national population growth rate, we have to take into effect immigration and emigration, because if we're talking about the globe, we're not going to have immigration globally unless people are leaving Earth. But anyway, so national, we have to take into effect, so the current birth rate plus immigration, so who's coming in. So remember, these two things are going to increase population, minus the current death rate plus emigration. So this would subtract the amount of people in your country divided by 10. So that would give us our national population growth rate. And then the doubling time is how we calculate how long it's going to take to double at that rate. So doubling time in years is equal to 70 divided by growth rate. So for example, if the growth rate is 1%, 70 divided by 1, it would take 70 years for the population to double. So I'll show you an example here. So it says, it's called the rule of 70, and it actually applies to economics and your bank account as well. So if you take the 70 divided by the growth rate of your bank account, it's the same concept, but this is talking about population. So 70, it says divide 70 by the population growth percent, and that equals the doubling time. So it comes from this equation, which I'm sure you probably remember from when we talked about exponential growth and the J-shaped curve. So here's a practice. So it says if the population of rabbits in an ecosystem grows at a rate of approximately 4% per year, the number of years required for the rabbit population to double is, so if we calculate that out, give you guys a minute to calculate it. So basically you take 70 divided by 4, which gives us 17.5. So 17 and a half years for the population of that rabbit to double. So that community of rabbits, it would take 17 and a half years to double at what they have. So whatever they have now, it would take 17 and a half years to be double. So that's a rule of 70, and that comes up quite a bit. So definitely make sure you understand the rule of 70. And I do have some practice in the math for you guys. All right, so here is our population growth here. It's going to definitely be an S-shaped curve because we don't have unlimited growth. So we have some type of limiting resource. So that's probably, like I said, food, land resources, water, things like that. But mainly food is a big factor. So here's that range. So that range is somewhere between 7 billion and maybe slightly over 10 billion. And like I said, scientists disagree on this because there's lots of factors. If we were to not be wasteful and use only what we need, we could be way up here. If we continue to use the way we do, we've already probably maxed out our carrying capacity. So somewhere in this range, depending on our use of resources. All right. So we talked a little bit about migration. So when we look at migration, that's just people moving into a country. So net migration rate just is the difference between immigration and emigration in a given year per 1,000 people. So that's how many people migrate from one area to another. So a positive net migration just means more immigration than emigration. So U.S. has a net positive net migration. We have more people coming in than leaving. And so we would have a positive net migration. All right, and then we're going to look at these. These are age structure diagrams. And so if we look at these 3 or 4 places, so Nigeria, and we analyze them. So one is looking at male, one's looking at female. And so looking at that Nigeria, there must be a reason why they don't have a very large population of older people. And so, so this is probably due to poor healthcare. They're a developing nation. This is pretty typical of a developing nation, is that their lifespan is not very high. So, but what this can tell us is that if they have access to good healthcare, that they might have a large growth rate because they have a lot of people that are in they're fertile, they're in their prime, they're having kids. So this could shift if they have better healthcare. But right now, this is indicating that there's probably something going on. They're not living as long as the average person in the world. U.S. So if we look at U.S., there's a large population, large portion of the population that is if we look at this, between 40 and 15 and 40, this is our light green. This is our usually childbearing age. So this would be where we might see lots of growth. And then we have kind of a large also population of people right above that. So between 45 and 75, our average lifespan is 78. So we've got just a few people living above that, but this solid area just indicates that we're a developed nation. Generally, we have good healthcare, good access to food, shelter, things like that. So that's kind of what it tells us. And then if we look at Germany, so Germany, they have a larger population of people that are not of childbearing age. So their population is actually declining. And so that's just because this area right here is smaller. So if this continues, then this eventually will be similar to what the US shows. And then China, so China has an extremely large population of childbearing age, and they have fewer that are above that. So there could be a population growth there. There could be a population expansion in China because of that. And this is usually nations that are almost developed or just in the cusp of developed nation. They have good healthcare. They're starting to live longer. They're reproducing, having more, or their ability to reproduce is higher. So then this just gives a little rundown of that, kind of what I described just a minute ago. All right. So moving on. So they're just population pyramids. So it's so basically, like I talked about, population is projected to increase in Nigeria as they get better healthcare. It's shrinking in Germany because the population that is childbearing is smaller. The growth is beginning to slow in the US. We're starting to get less down here. So basically, we'll look at these a little bit more later, but definitely have an idea of what these mean. So Nigeria, developing country, they generally don't have good healthcare, but maybe they are getting there. Population is starting to slow. Population is slowing. And then this is beginning to slow. But there is a potential if they don't take measures like they have in the past of kind of not allowing people to have more than 2 kids. So anyways, so just kind of understand what these mean as far as developed and developing, and if their population is projected to grow or not, and maybe why.
Russia, with the largest territory in the world, has roughly the same total population as Nigeria, a country 1/16 its size. But this similarity won't last long. One of the populations is rapidly growing, while the other is slowly declining. What can this tell us about the two countries? Population statistics are some of the most important data social scientists and policy experts have to work with. But understanding a country's situation and making accurate predictions requires knowing not just the total size of the population, but its internal characteristics. such as age and gender distribution. So how can we keep track of all that data in a way that makes it easy to comprehend? Complex data is more easily interpreted through visualization, and one of the ways that demographers represent the internal distribution of a population is the population pyramid. Here, the data is divided by gender, with females on one side and males on the other. The population numbers are shown for each 5-year age interval, starting from 0 to 4 and continuing up to 100 and up. These intervals are grouped together into pre-reproductive, 0 to 14, reproductive, 15 to 44, and post-reproductive years, 45 and up. Such a population pyramid can be a powerful predictor of future population trends. For example, Rwanda's population pyramid shows it to be a fast-growing country. With most of the population being in the youngest age groups at the bottom of the pyramid, the number will grow rapidly in the coming years. As today's children reach their reproductive years and have children of their own, the total population is almost certain to double within the next few decades. For our second example, let's look at Canada, where most of the population is clustered around the middle of the graph. Because there are less people in the pre-reproductive age groups than there are in the reproductive ones, the population will grow more slowly as the number of people reaching their reproductive years decreases. Finally, let's look at Japan. Because the majority of its population is in its post-reproductive years, and the number of people is smaller at each younger interval, this means that at current rates of reproduction, the population will begin to decline as fewer and fewer people reach reproductive age. Comparing these three population pyramids side by side shows us three different stages in the demographic transition as a country moves from a pre-industrial society to one with an industrial or post-industrial economy. Countries that have only recently begun the process of industrialization typically see an increase in life expectancy and a fall in child mortality rates as a result of improvements in medicine, sanitation, and food supply, while birth rates remain constant, leading to a population boom. Developing countries that are farther along in the industrialization process begin to see a fall in birth rates due to factors such as increased education and opportunities for women outside of childrearing, and a move from rural to urban living that makes having large families less economically advantageous. Finally, countries in advanced stages of industrialization reach a point where both birth and death rates are low, and the population remains stable or even begins to decline. Now let's take a look at the projected population pyramids for the same three countries in 2050. What do these tell us about the expected changes in each country's population? And what kinds of factors can alter the shape of these future pyramids? A population pyramid can be useful not only as a predictor of a country's future, but as a record of its past. Russia's population pyramid still bears the scars of World War II, which explains both the fewer numbers of elderly men compared to elderly women, and the relatively sudden population increase as soldiers returned from the war and normal life resumed. China's population pyramid reflects the establishment of the one-child policy 35 years before, which prevented a population boom such as that of Rwanda, but also led to sex-selective abortions, resulting in more male children than female children. Finally, the pyramid for the United States shows the baby boom that followed World War II. As you can see, population pyramids tell us far more about a country than just a set of numbers, by showing both where it's been and where it's headed within a single image. And in today's increasingly interconnected world, facing issues such as food shortages, ecological threats, and economic disparities, it is increasingly important for both scientists and policymakers to have a rich and complex understanding of populations and the factors affecting them.
All right. Well, I hope that was everything you wanted to know about pyramids. All right. So a couple other things just to talk about here. The total fertility rate is how many children a female can have in her lifetime. So the U.S., right now we're at 1.8. So that means that our population is increasing by 1.8. So developed countries' replacement level is just over 2. So this is something I want you to think about. Developing countries are just over 2.1. So why the difference? So think about it for a minute. So developed countries have better healthcare. And so developing countries maybe lack of hygiene, lack of healthcare, lack of proper facilities, food and water, that kind of thing. So their death is, they could die at a younger age. They might not live as long. And so to replace our levels, so for us, if we want to stay at the same levels, ours is just over 2. And developing countries is over 2.1. So they have to have a slightly more kids in order to keep their rates because of the high child mortality rate. Right. So if we look at the life expectancy here, U.S. average is 78 years. The global average is 72. And so, so it's a little bit higher in the U.S. Our standards of living, our hygiene, healthcare is pretty good. And so we have a expectancy that's higher. And then you can also see anywhere that's dark green does as well. So this generally is our most developed countries are the ones that have the highest life expectancy. And then the ones that have the lowest are our developing countries, the ones with the least infrastructure. So the least healthcare, the least access to clean food or clean water and food. So those generally are the ones that are lower. All right. And then if we look at the mortality rate, so the infant mortality rate is much higher in these areas that are red. It's lower in the areas that are green and yellowy. So basically, that's also due to healthcare. So it's due to lack of medicine in these areas, lack of maybe clean food and water, or clean water and food. And so basically, developing countries tend to have a higher infant mortality rate. And that's why their replacement level is slightly higher because they have a high mortality rate as a child. All right, and then this is showing something else to think about. So here's different countries, and then you can see people with HIV infections. So generally low, except for when you get to sub-Saharan Africa, it's extremely high. And so this can be a limiting factor for sure. So if we look at that life expectancy in sub-Saharan Africa, we go back a couple slides, it was pretty low. And so that correlates with a high infection rate of a disease that causes mortality. So that's definitely a limiting factor here. It's not really a limiting factor anywhere else, but definitely in sub-Saharan Africa, just because of lack of healthcare and lack of proper information. So education for the people that live there. All right, and that's it. So hopefully you enjoyed, and I will see you next time.